Hello, welcome back. I'm Savalian, a software dev/creative, and today I'm going to talk about connecting different systems of code together, or at least how I approach it. First, what do I mean by system? A system in code is anything that is logically separate from other things and sort of self-contained. So the inventory system, the quest system, the dialogue system, all of these things are logically cohesive and they contain some feature or some interaction or capability that is separate from other things, but they might need to talk to the other systems. So the quest system might need to talk to the inventory system to deliver a reward. The dialogue system might need to talk to the quest system to begin a quest. So they're not completely separate, but they do represent something that is its own thing. And that's kind of the idea. And as far as code organization goes, Unity can be a little bit tricky because of how it's built. So Unity uses something called mono behaviors to hold all of their engine code. And in order to interact with the engine at all, you need to use a mono behavior. But all of your code doesn't need and shouldn't be a mono behavior. So what sorts of things do you need a mono behavior to do? Create game objects, handle animations, play sounds, anything that the engine does for you, load 3D models, all of these things you need to use a mono behavior to do because it needs to be able to interact with the engine. But mono behaviors are weird because they don't have constructors. They can only be created by other mono behaviors that are connected to the Unity engine, and also they're more difficult to test because they're harder to create and manage, and they're just not as flexible. It's a little bit more difficult to move them around and change them like you could with a plain C# object. And then there's also just the tendency as especially as a beginner programmer, to put a lot of stuff into one class. So that's another thing I think about, is keeping things concise and relevant and easy to maintain. So how do you actually organize code in a Unity project? I'm going to talk through some things I do with my loot drop system, which I recently refactored as an example. And just as a rule, I do a few things with Unity projects. The first thing is that I do keep the game logic away from engine code as much as possible. So whenever I can, instead of putting something in a mono behavior, I put it in a plain C# script, and then I only use mono behaviors for engine specific things. So one of the things I'll talk about later is how I have a board unit class for each unit, which has things like its position on the grid, its current health, its current state, whether it's alive or dead, what actions it's planning to take next. All of that is in a plain C# script, but then I have a unit component. If I go out here, we can actually inspect it. I have a unit component. Where is it? Right there. Which handles the nav mesh stuff, navigating actually in the Unity space, the animator, instantiating particle systems, displaying a health bar. So all of the data underneath that determines what is happening with a unit is in that board unit script, and it's surfaced to the engine through this unit component. So if that doesn't quite make sense yet, hang in there. We're going to go through a little bit more specific code in a bit, but that's the idea, is keeping the game logic, the decisions, the actual code that's running the game separate from the engine code. And another thing I do is try to split up code so each bit of code only does one thing as much as possible. Keep things small. Think critically about the inputs and outputs of each class, kind of, if that makes sense. So like looking back at the inventory system, which currently just handles adding borbs and removing borbs. The input obviously is adding things to the inventory, and then the output would be getting back what is in the inventory so you can sort of see what you can do with it. Does that make sense? I hope that makes sense. So the end goal for what I'm going to talk about today is actually this here. An enemy dies, it spews out Borbs. At the end of the round, the Borbs are slurped up. I do think I need to balance this out a little bit because I'm not getting enough to actually do anything round to round. So we might actually die here, but we'll watch this again in action. So the system is the combat system, enemy dies, that talks to the arena loot system to spawn all these Borbs, which then talks to the inventory system to put them in my inventory at the end of the round. That's all the code we're going to look at today. So when I started this work, I had some of the pieces done. I had the combat system done, of course. I had a basic inventory that let you add resources. I had a class called Arena Loot, which represents the loot that is on the ground in the arena before it goes into your inventory, before you pick it up. And then I also had the Loop Manager, L-O-O-P, Loop Manager, which handles transitions between all the phases of the game. So it handles when you go from planning phase to action phase, back to planning phase, until you get to the end phase. What I didn't have was all the visual stuff, all the engine stuff, actually spawning the Borbs and displaying them on screen. And I also had some things kind of hooked up in weird places. Like, for example, the Arena Loot class was responding directly to unit deaths and spawning those Borbs on its own. I was also triggering the pickup of the loot in the Loop Manager instead of outside of it. So it was saying, okay, we're at the end of the action phase, let's pick up all that loot. And then because I didn't have anything visual, it was all happening in logic only. So the player would see nothing, but then at the end of the round, they would be given some Borbs. Now we're gonna get into the code. I was a little worried this would be kind of hard to follow, a little bit too hard technical, but as a young developer, I think I would have really liked seeing an in-depth look at something like this. So I'll try to be as clear as possible, and if you have any questions, you can always ask in the comments. Okay, so even though when I implemented this, I kind of did a little bit of back and forth, adding things in different places, I'm gonna move sort of directly through the code from the start, which is when the enemy dies and the loot spawns, to the end when the loot is picked up. So the very first piece of this is the enemy dying and dropping the loot. Previously, I had the Arena Loot class listening, subscribing to the event of the enemy dying, and spawning the loot within. But I wanted the enemies to decide their own loot. So here in this, I have a scriptable object. This is how I define all of my critters. The critters and the enemy monsters, the naming is a little fuzzy, but I have all these things like their name, description, how much it costs to buy them, and I've added just these two little integers, the low end of the Borbs it drops, and the naming of this I'm realizing now is a little bit confusing, but this is the low end of how many Borbs this unit can drop, and the high end. If I was making a game with more types of loot, I would do this differently. I would do probably a list where each item in the list was a percentage and then a reference to the item. So like a loot table, basically the percentage of each thing to drop. But since I only have Borbs, and I think that's the plan, to go forward with only dropping Borbs, just to how I have everything set up. So this is really all I need, and I think this is fine. So we have this in the unit SO. Then when the board unit is created, it has access to this information. And I already had this unit death function, which previously would just say that they're dead, change the status to dead, and then also launch off that event. But because I wanted the units to be responsible for their own loot drops, I've added this here. If this unit type is an enemy, we're going to drop some amount of Borbs. I've decided to multiply it based on their level, so I've just got a little multiplier here. And then I use the random range to get a random number between the low end and the high end. And then I do use an event that I've created called loot dropped, and I send the amount. So that loot dropped event is available for people to subscribe to. And in fact, the unit component subscribes to it. So as we're moving through this code, we're sort of moving forward through the process here. So the board unit has detected a death. It uses this event to let the unit component know, which remember is the mono behavior that I use to sort of display the 3D model, run animations, do particle stuff, things like that. But the reason we need to get the board dropping through the unit component and not just send it directly from the board unit to the arena loot is because we need the position. We need the position in the world to drop these borbs. So literally all I'm doing in this one, and you'll notice I am giving this a reference to the arena loot, so it is interacting directly with the arena loot class, which we'll talk about next. I'm basically just grabbing a position to spawn these from. It's above the unit just a little bit to avoid collisions. And then we're calling drop loot, the amount, and the spawn position. So now, moving in here, drop loot. This is what we're calling from the unit components with the amount and the position. So we're creating a new stack of items, and when I initially designed all of this, I had more than one kind of loot, so we have a little bit, this is a little bit clunky. We don't really need to define types of resources when I have only one, but I just left this in here because I didn't feel like refactoring it right now. But basically this just creates a stack of borbs of the amount that we've passed in, and then we add it to our internal list of loot drops, which is just a list of stacks. And then we do one more event, loot stack dropped event. We pass in the amount and the position. So what we're doing in this class is this class handles the game logic of what's on the arena. So most of this was already done before I did this little refactor, but all this code is concerned about is in logic, in sort of a virtual space, how many items are in the arena and what types of items are they. And then we have these functions to drop the loot, collect the loot, clear the loot. This is basically an inventory for the ground. That's basically what it is. And it doesn't do anything with game objects, with the physical things in the game window. All it does is manage in theory how many items are in the arena. So we have this list here, we're adding that stack, and then we're sending out this event saying this amount was dropped at this position. That event is listened to by the board drops component. And I didn't listen to the event in this class. I listened to it when all of this is initialized. So here my drops component listens to the loot stack dropped, and then it also listens to loot stack slurped, which is what I named that. And then this is the mono behavior. So this does handle game objects, positions in Unity space, physics. I do a little bit of physics work in here. And then the other thing that mono behaviors can use are coroutines. So little async functions that are very useful for doing things over time in a certain order. So basically what I'm doing here, when I get this event, drop borbs with the amount and the position, I go into here and first I wait a little bit, and this is because the enemy needs to actually fall down. This event goes off like immediately when they die, but they still need to animate their death. And so I wait for a little bit. This is not exact. It doesn't line up exactly with their demise, but it's close enough. And then for each thing I need to instantiate, I create a new game object from a prefab that I've made, which has the board model and a rigid body and a collider. And I think that's it. I spawn it at the position I was given and just a normal identity rotation. No rotation basically. And then I grab the rigid body component, I generate some random numbers, and then I just sort of like shoot it out in a random direction by adding this force. And then I make sure to keep a reference to this game object so that I can destroy it later. So I've just got a list of those that I'm adding to. And then each borb I do, I just wait 1/10 of a second so that they're out of the way when the next one is instantiated to avoid. I had these really wild collisions at first where I was spawning them all at once and they were just kind of exploding because they were all in the same position at the same time. So just by waiting a little bit, I let that first one fly out of the way before I make the second one. And that's it for creating the borbs, adding the borbs to the arena loot. And if we go back, we can see we also have this round has changed. This listens to the loop manager for when the round has changed, so we can check the phase. If the round phase has changed to prep, we can collect all the loot. So we're no longer directly calling collect loot from the loop manager. The loop manager has an event for when the round is changed that we just listen to here. And so when that happens, we tell the visual component to slurp up all the borbs. And then for each stack in our list, we add that resource to the player inventory and then we clear it. Easy. So we have this happening in the game logic, and then at the same time, we are calling this coroutine to slurp up the borbs. This was actually kind of precise for me to get right. So what I wanted to do is this very smooth sort of, all the borbs fly up into the air and then converge on the player. They all fly into the player, basically. So I have no idea if this is the most performant way to do this. I haven't worked very much with the physics in Unity. I usually animate stuff. I don't usually use the physics engine. So what I'm doing is getting references to all the rigid bodies, so I have them. I am going through each one. I'm adding that upward force to launch them up into the air, waiting for just a second or just a quarter of a second, and then I'm looping basically until we're done, which we're saying when all the rigid bodies have been destroyed, we're done. Or I'm giving it a 5-second timeout just because it's really kind of wobbly. The physics engine doesn't work exactly the way I expect it to all the time, and so we're adding a timeout on here just to keep things from staying alive for too long. So basically for each rigid body, as we loop through here, we're checking how far away it is from the player, which you can do by subtracting the destination from the object's position. If that distance is less than 1, it's close enough in my opinion. We're gonna add it to this list to be removed later because it's there, it's done. Otherwise, if it's farther than 1 Unity unit away, we're gonna turn off gravity and we're gonna add a force so that it moves towards the player. So we're using the same vector, we're normalizing it just to make it less. So this basically takes the vector and makes it 1 unit long in whatever direction it's pointing. So we're using that, and then we're using this velocity change type of force mode. I'm not exactly clear on the different force modes. I just kind of played around with them until I got something I liked, and this one seemed to work. And then outside of that for each, we're going to remove all of the ones that are done, and then we're also going to go in and destroy the game object for all of the ones that were removed because we don't need them anymore, they're done. And then at the very end, if we're out of rigid bodies, if we've removed them all, we're done. Otherwise, we keep looping until we hit that 5-second timeout, and then at the very end we just destroy all the ones that are left and we clear the list of game objects here. So that is how I'm slurping up all the borbs, and that's pretty much how everything works. So just a quick recap. The unit dies, the unit reports its own death and calculates how many borbs it's going to drop with a little bit of randomness in there just to make things fun. That is sent up to the unit component, which adds in the position it's at. so that they can be dropped in the right place. The arena loot gets called drop loot, and then it creates that resource, adds it to the loot drop list, and then sends out an event to the Borb drop components, which it does all the visual stuff in response to what the logic underneath it is doing. So that's it. That's the whole thing. And what I was hoping to demonstrate with all this is how useful events can be. You do need to make sure you unsubscribe from them, or that can cause some little memory issues that can really add up later if you don't deal with it. So you do need to make sure you are unsubscribing from events, which is why I have this composition script where I handle a lot of the subscriptions, because I can also then, when this is destroyed, go through and unsubscribe from all of those and sort of manage how these life cycles are taken care of. But you don't necessarily have to do it this way. You can do it in the component if you want. But I just find that having events at sort of the input and output points of certain components, of certain C# classes, it can make it much easier to separate different pieces of code, different systems. It can make it easy to understand how information is sort of flowing through your game, or how action is flowing through your game. So that's the whole system. This is pretty much how I approach all of my game systems. I look at where different pieces connect. So like where the unit system connects to the loot system, and I try to really define how things are passed between those two things. So whether I use events, like I use them here to signal to the component what is happening. I do the same thing on the board unit to signal to the unit component. Whether I initialize something with a reference to something else. I do this more rarely, and in fact here I think I could actually use events instead. I think that would be fine, but however you do it, really defining how things interact with each other and keeping that communication as clean as possible just makes the code easier to work with. It makes it easier to figure out what's happening when something's going wrong, and it makes it easier to add new things or change how it works when you have things consolidated like this. So if I did want to change, if I wanted to change what the Borbs do on the arena, all I have to change is in this Borb drops component. If I want to change how many items are dropped, right now all I have to change is in the unit scriptable object, but I could also change like how the randomness is done. I could change that in here, but by keeping all these pieces sort of in their place, I don't have to deal with a bunch of spaghetti code that's like tangled up all over the place and try to figure out where something starts and where something ends, because I've done the work to really just define the responsibilities for each of these things. So that's all I have for you today. A fairly technical video, but I hope it was helpful. I've been doing Game Dev December, where I work on my game every day in December and post for accountability on my Instagram. And this is one of the things I worked on. I've worked on so many things at this point. It's actually been really great. I've gotten a lot done. You can see the visual difference. I've got a lot more stuff in here, and I'm just so happy. This monthly challenge I've made for myself is really working out. And there we've seen the board system in action, so that's fun. But that's all I've got. So don't forget to subscribe if you haven't already for more videos about game development, game reviews, art, creativity. I touch on a lot of different subjects depending on how I'm feeling. So I'll be back soon with another video, and I hope to see you there. Thank you, and bye.